Yeah. Cool. All right. What time we might start jumping into the
the next one.
session a little bit early then.
Get out of your way.
Yeah. All right. So we're going to kick off the next one. The next one we're going to do is shared pointers and memory lifetime. So we talked a lot about raw pointers in the earlier sessions and how, if you don't release the memory, it's a memory leak. We have all sorts of, it sucks, right? It sucks. It's error prone. You're gonna have to either copy memory around when you're wrapping pointers in classes, or you have to be really careful about when your memory is freed or released. And really, we don't want to do that. That's a lot of work. What we really kind of want to do, and this again sits outside of the UObject system, which we will get to in a later session, is we would like to have reference counted memory. So if we declare some really low level class, this is just, we can put whatever we want in here. Let's just make a string, maybe an int. And we want to put this on the heap, right? Unreal provides a shared pointer library that is going to reference count memory for us, and is going to make sure that memory gets automatically released and freed when it is no longer in use. So we can do TSharedPointer and then the class that we're using, and we're going to allocate we're going to put the TSharedPointer on the stack, and then we're going to create a new ftest class. Now, we haven't used the new operator here. We've used this MakeShared template. The MakeShared template basically calls the new operator for you, and then also passes any constructor parameters in. So let's say we make a constructor here, and I'm just going to initialize some stuff, initialize all the fields out, and then we can pass in what we want the string to be initialized to. And you'll notice here that we're taking in an f-string reference. The compiler is inserting the f-string constructor for us so that we can pass the f-string into it. And then this all works. It creates an ftest class on the heap. We get our TSharedPointer back. This is actually going to be a TSharedRef. I'll get to the difference in just a moment. And now this is reference counted. So because the only reference to blah currently, the only reference to this ftest class is in this local variable blah, when begin play exits, the last TSharedRef will be destructed because it's the TSharedRef is on the local stack, so it is on the stack, so it will have its destructor called for us by C++. When the last reference to that memory is gone, TSharedRef will be like, okay, it's time to delete that memory, and it will call delete for us, and we don't have to explicitly remember there's 14 things pointing to this, and we need to track our memory. We can just use TSharedRef. So when do you want to use raw pointers, right? Can we just use TSharedRef for everything? You're going to use raw pointers when you actually want blocks of memory, right? So give me a block of memory, and then I believe it is fmemory malloc, and we want 200 bytes of memory. Give me 200 bytes of memory, and this you do have to free later. So if I want to get rid of that memory, I go block of memory. You're probably wondering why we use fmemory malloc and fmemory free. Yeah, we could use well, in C it's malloc, right? C++, it'd be new uint 8 200, I think, or something like that. No, that's wrong. Something like that, yeah. But if you're just doing blocks of memory and you know what size you want, we just by convention use fmemory malloc. Someone in chat asks, I've heard of RAII, which stands for Resource Acquisition Initialization something. In the context of C++, shared pointers and refs is essentially Unreal's RAI system. So I want to say not really. RAI is with the resource acquisition and initialization is what we were doing in the earlier workshops, where we were making sure that our constructors and our copy constructors and our destructors were responsible for the memory inside the classes that we're defining. Classes were responsible for managing the lifetime of those. TSharedRef and TSharedPointer it's just reference counter memory. Like it's nothing. The thing that's responsible for actually like releasing the memory is simply when you no longer have any references to it, and it just is released by the shared pointer library because nothing else references it to it. I wouldn't really equate that to RAII because they are quite different. In RAI, your class is responsible for freeing the memory or copying the memory or managing the memory. In this, it's not really aware of what it's managing. It's like just sort of like, it's a thing, and you don't have any references to it more, so I'm just going to call the destructor and delete it. Hopefully that makes sense. So we use fmemory malloc and fmemory free for just blocks of memory if we happen to need them. You probably won't unless you're doing things like network packets or something like that. You probably won't need to use that. So you would have seen before I used TShared. So the reply was, got it. So when using TSharedPointer, you're still responsible for creating the proper constructors and destructors. So yeah, you're still responsible for, like, I've created the constructor here. And like if I needed to, and like if my, that's a good point. If this class was allocating memory, like if this had a pointer in it, right? And in my constructor, I was doing pointer if memory malloc allocating 200 bytes of memory onto the heap, then I would still be responsible in my class's destructor for calling fmemory free on that pointer, right? Like the shared pointer system is not going to do that for me. It will call, call the destructor on ftest class when it's time for it to go away, but we still have to manage the memory inside of our class. Again, you're probably not going to be using raw memory blocks too much, but yeah, it is important to note that you still have to do your RAI inside your classes for raw memory blocks that you're using. So before the first time I was writing this code, you saw me use TSharedPointer, and it now says TSharedRef. What's the difference? So TSharedPointer can be nullable. TSharedRef cannot be nullable. Like, this is not going to work. It's going to complain at me. TSharedRef can't be nullable. TSharedPointer can be nullable. When you call MakeShared, because MakeShared's always going to give you an object that's actually constructed, you get back a TSharedRef, right? Which is why we get that there. There's one other way to construct things. So if we go TSharedRef, ftest class, blah2, we can also do MakeShareable, and we can do ftest class text hello. And you might be thinking, isn't that the same thing? And you would be right. It basically is the same thing, but there's one really critical difference. When we use the first invocation here, the constructor has to basically be public, or it has to be accessible to the MakeShared function. Like the MakeShared function itself has to have access to the constructor. And if you're making a class where the constructor is private and you don't want it to be generally constructible, you only want, for example, internally, like if you had a static ftest class, TSharedRef ftest class, make a thing, right? If you wanted to do MakeShared here, MakeShared can't access the constructor because MakeShared doesn't actually have access. Sorry, I'll make it clearer. I'll put that up in a private section. MakeShared doesn't have actually access to call the constructor here. I think this is not going to work. So instead, what we can do is if we do MakeShareable, and then we call the constructor ourselves, then we allocate the block of memory, and then we pass it into MakeShareable, which then puts it into the shared pointer system. So then once this returns, this memory is now managed by the TSharedRef that we're returning. And so this is a way of calling like private constructors and other things that MakeShared can't access if you want to do this sort of like protected constructor pattern. Where did I put that constructor? Let's put it down there. Now, there's one other thing that I need to cover, which is TWeakPtr. ftest class weak. Now, this is a way of having a pointer to something that is managed by the shared pointer system, but that it won't keep the object alive, right? So like if we have a TWeakPtr here, and let's say that blah and blah2 are both gone out of scope, like there's no shared pointers or shared references left to this memory, the weak pointer will not hold it open. And so if we look at the weak pointer API, we can't just like, so if I go here, blah2, right? We've made this thing. We can just access the fields, right? Because the fields up here, we've set them as public, so we can just access them straight away. We know the TSharedRef is going to be valid. For the TSharedPointer, if I change that to TSharedPointer, we can still do this. The onus is on us to make sure that blah2 is not null when we try and access this, because blah2 can be null or it can be a pointer to this memory address, but it's never going to be garbage. Like if we use raw pointers and there's no safeties on, it could be anywhere, right? In this case, if we want to just make sure that blah2 is valid, you can either, go, is it not null pointer, or you can just do is valid. Now, a few things you might notice here before I turn to the weak pointer stuff. First of all, see how we're calling is valid when we're using the dot? That's because is valid is a function on the TSharedPointer class. Like if I go here and I look at this, this is, scroll up. I think it's very, very long. This is on the TSharedPointer class. So, right, so we're calling is valid on the TSharedPointer. This operator here, it's going to be fancy. But this operator here, remember how we talked about the arrow operator being used to access members of pointers? Because TSharedPointer is not a C++ pointer, right? We have to, the engine, the TSharedPointer class, implements an operator overload for the arrow so that it will return a pointer to the object, which then allows us to do our member access as normal. Yeah, so that's what that API looks like there. Sorry, just before I come back to the weak pointer, there's a few other things I want to cover that I've realized what I'm doing. If we want to turn a TSharedPointer into a TSharedRef, we use TSharedRef. And this is because you might have a function that takes TSharedRef ftest class, and then that way that function that's taking that TSharedRef, it doesn't have to worry about it being null. It's guaranteed from the fact that it's taking a TSharedRef instead of a TSharedPointer that it's not going to be null, right? And so if you've got a TSharedPointer and you want to pass it into something that is relying on it not being null, then we call TSharedRef, which converts it to a reference, and is like, if it's null, if the pointer is null and you call TSharedRef, it's going to throw an assertion and be like, nope, you can't do that, because references can't be null. Right, back to weak pointers. So with pointers and with references, with TSharedPointer, TSharedRef, we can just use the arrow to just access members and call functions on the thing. But the weak pointer explicitly it may not exist. At any point in time, it may not exist, right? So before we can use a weak pointer, we have to pin it. And pinning returns a TSharedPointer. So what you would do is you would normally have a pattern like, this, where you're basically saying, okay, we're going to pin the weak pointer. I'm going to make this very clear for everyone's benefit. We're going to pin the weak pointer, and we're going to put it in this TSharedPointer. And now, because this TSharedPointer is in the scope, this TSharedPointer exists, for the entirety of this if function, the reference will not be freed, right? Because we now have a strong pointer to that memory. And then when it goes out of scope, it's available to be freed again. So if that was the last remaining strong pointer, then the memory is gone. And this also means that, you know, if we hit the else branch here, it means the memory has gone away, right? Like when we hit this code path, the weak pointer is now pointing to nothing because the memory's been freed, and you kind of have to handle that situation. A question in chat is, if you have a TSharedRef T class, F class blah2, so this is if I just go here and make it, and you call the destructor on blah2, does that mean the reference is pointing to something that's null or garbage memory? You can't call delete on this because this is not a pointer. It's a shared pointer in the sense of like Unreal's shared pointer library, but it does not have a pointer. It's not actually a pointer type, right? So you can't call delete on it. You can't call the destructor on it. The only way for the memory to be released through TSharedRef is for all of the references to go away. And you can't release it earlier than that. Hopefully that answers that question. What else we got? All right, the last thing we're going to cover, or the last thing I'm going to cover is TSharedFromThis. Someone just asked, UObjects are not compatible with these shared pointers, right? I think we would then use TWeakPtr. If yes, why is that? Yes, so you are correct. These are not compatible with, you can't have a shared ref or a shared pointer to a UObject. The reason is that this is all reference counting, right? So we're reference counting using the shared pointer library. UObjects are garbage collected, and they're completely different memory management systems. You can have a TSharedRef or a TSharedPointer inside your UObject class as like a field or something, but to go the other way, you are correct. You would use a TWeakPtr. So, you know, I think it's something like this. It's been a while since I've done that particular thing, and then you would set it to whatever it is, and then that way, because UObjects are garbage collected, there's no such thing as a strong object pointer. There's no such thing as a strong UObject pointer because they can go away at any time. So you're always going to see this weak object pointer there. We'll talk about UObjects a bit more later. We've got another session coming up, I think, in this block. It's at the end. We'll talk more about UObjects then. So what we're going to talk about is we're going to talk about TSharedFromThis. So TSharedFromThis is a interface class. It's a thing you can inherit from. And what this allows you to do, sorry, I'm going to do a quick time check. I think we're still on track. Yeah, I think we're still on. Yeah, we are. So what this does is this now means that on your test class, there is a new function called asShared, right? And this is on the class itself. And this will give you back a shared reference. This will give back a shared reference if you only have the object, if you only have the reference to blah2, you don't have the actual, if you don't have the shared ref, you've only got the test class, this will give you a shared ref. I'll give you an example of where this is useful, right? Let's say we have a function and it accepts a reference to an ftest class, right? Now, this function in particular doesn't care where blah is, right? If we're using the shared pointer system, right, it's always going to be on the heap, right? But like maybe this function doesn't really care whether it's on the heap or whether it's on the stack. Now, of course, we're going to use something to get out of this situation in a moment that is going to mean this function does care about it being on the heap or being on the shared pointer system. But you can imagine that you might have this is something we see in the online subsystem APIs, where it's like the interface for an online subsystem just takes like the const ref, right? Because it doesn't know if the implementation of the function is going to care about this or not. So you can call it depending on which way you want to use it, right? But inside this function, right, inside this function implementation, we've only got the const reference to the ftest class. And we want to get the shared pointer, right, to, why is this not giving me Am I missing something here? I'm not sure what Visual Studio is doing, because it definitely has. Okay, I think IntelliSense is getting a bit weird. But what it does is it adds this as shared, which will then return a shared pointer to the ftest class. So, what is it complaining about? Oh, it's because of the const, I believe, because we've got a reference to a const, right? So if we wanted to do that, yeah, because the const here is not a const. It's not a const on the reference. It's const on the ftest class. So now we have a shared pointer to the to a const f class, so ftest class. The advantage of this is, like, if we've got this coming in as a reference and now we want to store it in something, right? Like, let's say we have a class. Oh, okay. Holds a test class. We might have a field that is a tshared pointer to a const ftest class. And if we want to make one of these and we want to put our ftest class inside it, we need a tshared pointer, right? We've only got a reference at this point in time. If we do this, now we can go, okay, blah as shared. And this is not, it's gonna be happy. Yeah, okay, that does compile. IntelliSense, what you're doing. And now we can actually hold a reference to ftest class longer than the lifecycle of accepts a reference. Even though we didn't actually come into it being aware, or even though we didn't come into it with a shared reference in the first place. So that is the value of tshared from this, is it gives you this as shared. The downside is that if you want to call as shared, the object has to have been created with either MakeShareable or MakeShared. If you pass in like a stack, if we were to go, right, ftest class, if we were to do this sort of behavior, where we've just put ftest class, it's just a temporary, we pass it in, this is perfectly valid code to compile, but when we call as shared, we're going to get a check because this isn't actually in, it doesn't actually have a shared pointer associated with it. And so there's nothing to actually give out here. Hopefully that makes sense. Anyway, that's all the topics that I had to cover for this session in terms of shared pointers and memory lifetime. If people got questions, I will go through them. Someone just mentioned there's T-strong object pointer. I have never used that myself. Oh, there is too. Interesting. I wonder what the behavior of this is. Okay, well, the description sort of gives it away, is that it will actually prevent it from being garbage collected. Because I was curious to know what happens if, like, the actor has begin destroy called on it, right? And you've got a strong object pointer to it. And it sounds like you might still go through typical finalization, but the memory will still be pointed to. Yeah, I've never used that particular pointer, but useful to know that it's there. Do you have any other questions? Doesn't sound like it. So